Okay, good evening to all. Here I am Deepa Vinod, Academic Counselor of MyQT. Here we are with another section on Introduction to Amazon Braket. The Amazon Braket is a fully managed AWS service that provides a primarily technology agnostic environment. Customers can design, develop, test, and run their quantum algorithms. Now, MyQT is a repository of world-class knowledge and wisdom contributed by the best minds in the field of quantum computing. MyQT operates across the globe through its vast network of affiliates and partner organizations. MyQT provides a wide range of offerings including training, certification courses, research opportunity, and consulting services. Okay, now I proudly introduce our speaker, Mr. Karthiganesh Durai. He's a software engineer turned into data scientist who's working on building quantum machine learning solutions. KG has Master in Computer Applications from NILIT and Master of Business Administrations from Puducherry University. Currently, KG is working as Chief Quantum Architect in Boson Qzai Corporation. He co-founded Quantum Computing India in 2019. KG worked in Dell Technologies, Bangalore, Synergy Consultant Singapore, Keppel Shipyard Singapore, and Alam International Singapore. Now, you participants and your appreciate willingness to cooperate and provide feedbacks to us. Your input is essential to the continuous improvement of our upcoming sections. Now, I invite KG to continue this section. Welcome, KG.
Thanks, Deepa. Good evening and good morning to all wherever you are. This section on Amazon Braket, most of the industry exposure starts from alternative or other hardware software platform for quantum computing. Recently, I had a chance to work with Amazon Braket. Though I had worked earlier also, but recently they have added a few more QPUs, quantum processing units, and I saw it is good time to talk about and introduce Amazon Braket to our community. That is the uh, mm, it's called motivation behind this session. So let me start the session, and I will go slowly because I'm expecting more people to join, because many of my contacts and mentees told that they want to join this Amazon Braket session. So let me go back to the, yeah, I believe all of you are sharing my seeing my screen share, right? It is showing PPT. Deepa, you are seeing PPT, right?
Yes, KG.
Okay, right. And let us move on to the next slide. This is our agenda. General introduction to AWS, then introduction to Amazon Braket, uh, then a little bit introduction to quantum computing. Again, that depends on the interaction of the attendees. If they want to hear the basic introductory concepts, we will go back. Otherwise, we'll continue focusing on Amazon Braket. That is the plan for the today's session. In this process, we also go to we will review what are the quantum gates, and then what is the quantum circuit, and what are the quantum algorithms. Then we will have a demonstration, end-to-end demonstration on Amazon Braket platform for building a QAOA based algorithm that will give us uh, an experience how to build variational quantum computing workflows using Amazon Braket. This is the agenda. Feel free to ask your questions post Q&A. It is not rigid. At the end of the day, there should be a takeaway for our community member. So I would like to spend time on explaining the questions, or we are open to discussion also. It's not only I'm explaining. If you know a concept, feel free to come forward, then explain for the benefit of the community. Okay. Our agenda is little bit flexible, and we have 2 hours. The session can happen somewhere between 1.5 hour to 2 hours, depending on the engagement of audience. If you are asking more questions, want to know more concept, we can continue till 2 p.m. 2 hours. Sometimes the most of the concepts what I'm having, it will be covered within 1 hour only. After that, based on the Q&A, we will adjourn the session. Hope the agenda is very clear to all of you. Feel free to interact because I know that this is most of us know because we are using Amazon for many of our workload. So here I will let us go with some introduction among the community members, if possible. Abhay, would you like to introduce yourself? Why you are interested in this Amazon bracket session, and where are you from?
Sir, hello, sir. Good evening, sir. Sir, I am from Delhi, and I have
Mhm,
done MSc in physics and have learned about the Python. So it is
mhm.
basically a link to my actually a course. Because I just read about quantum mechanics in my graduation and post graduation, and I want to make a career in it. So that's why.
That's great, great. Thank you. Welcome to our community.
Thank you, sir.
Now I want to hear from Vinesh. Vinesh, you're comfortable?
Yeah, EKG. Yeah.
Yeah, thanks, Vinesh.
So
Please go ahead.
yeah, I'm quite new to this quantum computing. Just wanted to see. I've heard about Amazon, AWS, but Amazon Bracket is something new to me. I just wanted to see how what Amazon Bracket is and how this can be used for quantum computing.
Great. Thanks, Vinesh. Knowing Amazon bracket will strengthen your confidence on quantum computing because that is really good platform. What so far I have experienced. There are many platforms. I'm not comparing the platforms first of all. So AWS bracket is one of the good. Uh, it's it gives multiple options for choosing the hardware. That is one thing I liked about AWS. Um, can we? Yeah, Ken is our speaker. So I would like to. What happened with the others? I saw Soundarya and Srihari. Okay. So in that case, we can continue with the Ken. Ken. Okay. Right. Um, Srihari, if you are interested, you can share about you.
Hello, sir. Yeah,
Yeah. Yes, Srihari.
field actually, and I would like to learn about quantum. Interested in to learn about quantum computing. I have
Mhm.
explored gates, quantum gates, and algorithms from which are available in the IBM quantum computing, and have
Okay.
taken participate in the events as well. I'm interested to learn about more about quantum algorithms related more, and interested to explore the optimization as well.
Great. Okay. Thank you. Thanks, Srihari.
Yeah, sir.
I think, okay, right. In the interest of time, I think we can continue with the session details. So based on, I believe that agenda is clear. Let us move on to the next concept. It is a small introduction about AWS. AWS Web Services started in early 2000. But prior to AWS, that Amazon is an organization which is selling books. They started with the books, then they started they grown as e-commerce. For their e-commerce, they built their own web services. In that experience, they thought that this kind of solution the industry may need for this kind of solution. So they started selling the platform what they are using for e-commerce. Then that became a hit. They realized that there is a potential market for cloud, and then The industries, the developers are looking for a more stable, consistent, and high performance cloud. So they started their services in the name of Amazon Web Services, AWS. So initially they started only three services: S3 for storage, EC2 for compute, RDS for database. So here you can see this is their EC2 logo, and this is RDS logo, this is S3 logo. But now they have more than 200 services. In it is really one of the largest pool of cloud services in the industry. So you name it, you will have a service in AWS. That is the one reason why AWS hold this market share. You can see here in 2015 is 10 times more infrastructure, but now it was reduced because major player came into picture. And as of 2023, they are starting operating from 31 regions and 1.3 billions of servers with high availability, redundant data storage, redundant power, and net jet zero power consumption. They are introducing a lot of concepts. So AWS is one of the market leader in the cloud services. Of late, they started a service called Amazon Braket. So Amazon Braket is one of the 200 services provided by AWS. Amazon Braket is a fully managed quantum computing service. So the fully managed service means they have all relevant services available within that service. For example, if you are building a quantum algorithm, you need an editor and a quantum hardware, and there is a messaging queue between your your compute device to quantum processing unit. Those communication, everything is managed by Amazon Braket. So that is one good thing about Amazon Braket, where once you establish all those things, that will run with managed services by AWS. And it is the main advantage is that speed up scientific research. Let me take lighter pen, lesser pointer. So here you can see it is scientific research and software development for quantum computing. So why they need a different services, that we are going to see why this there is a separate service for quantum computing, which is used for scientific research software development. So the initial steps are build your algorithms on managed Jupyter. See, this is the beautiful point, and that is why most of the people like about this one. Managed Jupyter notebook. So you can build your algorithm in a Jupyter notebook or in our own development environment, meaning that, or in your laptop also. So it can be either in AWS managed Jupyter notebook or in your local laptop, even Visual Studio Code. Then we can test the algorithm either run on a simulator or high performance simulator. So the high performance simulators will incur certain cost, that which we are going to see after some time. Then after we tested that algorithm, confirmed that it is working, we can go for a real hardware, because running on a real hardware will really cost more. So usually we will perform after testing phase. That is why in the testing phase they are allowing local simulator or high performance simulator. After that, we can choose which hardware is suitable, whether it is Harmony, IonQ Harmony, or QERA, or OQC, or any high performance simulator provided by Amazon, like state vector or tensor network or density matrix. These are the various simulators available in Amazon Braket, where you can run your quantum algorithms. That is where this stage. Then analyze the result. If anything change required, come back make change, then test, run, analyze, repeat this step. So this workflow can be done easily using Amazon Braket. That is the application of Amazon Braket. Is it clear? Okay,
Yes, sir.
right, good.
Yeah, yes, sir.
Now, let us move on to the Amazon Braket services. Because in Amazon Braket, we have to introduce a lot more concepts. Actually, this one will be the number of services record. So I kept it blank in that will be, but how the Amazon Braket is organizing these things, or what is the main components. One is QPUs and simulators. As I told you, Amazon Braket supports um, multiple hardware. As of now, these three companies' systems are available. Actually, I want to show. Um, while let me share my other screen also, because I have to show you the Amazon Braket interface. So let me switch over my. Uh, yeah. Hope you are seeing my screen in Amazon Braket, right? So this is, you can see here, this is my QT login with Amazon. And okay, let me increase the font size. It is too small. Yeah, now I believe it is clear, right? You can see here it is my QT account. And if you go to Amazon Braket, how to come to Amazon Braket? You have to type here in the search. Type Braket here, then it will show all the available services. Then select Braket. That Braket dashboard will come. I will go slow. If you want to go slow, let me know. I will explain. Okay. It is very slow. Okay. Right. Now it is loaded. In this dashboard, you can see option to view your devices. Click the devices. That will show all the devices whatever we are having. Okay. And here, if you click show retired devices, earlier what are the services provided by Amazon. Now we can see here D-Wave was also available, but now it is moved to marketplace. Um, so marketplace is more flexible model. Then you can see Xanadu Borealis, which is used for photonic QPU for Gaussian boson sampling. And there are Aspen M1 to M3 11 Oxford Lucy. These are all various devices. If I remove these retired devices, then this is the, and these are all available now. All others are it takes some time because their availability is somewhat tight. Here you can see here 256 qubit analog neutral atom based QPU. So there are various devices. That is the reason why Amazon Bracket provides you multiple um, target QPUs and simulators. Let me come back to our presentation. So actually, I switched the screen because that will give you a flavor of real application screen rather than seeing the PowerPoint deck. That will give you the feel of uh, confidence and then comfortable level. Yeah, we are discussing something real service provided by some organization. In this case, it is AWS Braket. Okay, right. So the QPUs we saw. Then, since it is hosted in AWS, it is the cloud environment which allow you to do your quantum computing workflow from any laptop or desktop wherever you are there. That is one advantage. And here it is not only quantum computing, it will use other resources also. For example, writing your notebook and getting visualizing your results. For all those things, you need storage and the message queuing, tracking, then For typing the notebook, you need one more environment which is called SageMaker. All those services are bundled into one cloud. Got the point, right? Then the hybrid approach where part of classical and then part of quantum work together to get the solution. That hybrid approach. Then they have quantum solution lab where you can collaborate with the experts of AWS, get their suggestion, get their help, or connect with AWS vendors. They will also provide you support. Those things are available. That is one good thing with the quantum solutions lab from AWS. That is one part which is helping customers of AWS to comfortably explore and then research the AWS Braket or Amazon Braket platform for their quantum computing researches and algorithms and applications. Whatever they want to test, they are not alone. If they need, they can get a helping hand. Hope this is clear. Right. Uh, so this is the Amazon Braket systems as of now available now. You can recall that we saw in the, I think I have to share my entire screen such that we will be able to switch between the applications. So here you can see this is my MyQT AWS login. Here you can see IonQ, Oxboard, Quantum Circuits, QERA, Rigetti. These are all four vendors, hardware vendor are called QPUs. And this is simulators. You can see here the hardware provided is AWS. And this is here you can see the description 34 qubit Amazon Braket state vector simulator. This is tensor network, that why the letter TN, and DM, which is density matrix. So these are the available devices. That is what you can see here. Um, so the brand name, the logos and all I put it for the, because this deck will be shared with you. Later you can review this deck to understand or review the concepts. Next comes, yeah, this what we had discussed as a screenshot, because that time we may not be able to come back to this. So here one thing about this device, see you identified one device, Rigetti Aspen M3. If you want to see more detail about that device, you can click on this hyperlink. That hyperlink will go to the device details screen or description screen, where you will see the status next available, then device ARN. This device ARN is important concept because this is Amazon resource number or resource that is the ARN. So this will be used inside your program to choose the target QPU or simulator. For example, if you want to run your program on a Rigetti Aspen M3, you have to use this your ARN. If you're planning to run on Harmony, IonQ Harmony, you have to choose this ARN. So this is the ARN for IonQ Harmony. Oh, I'm making sense now, right? So area 2, these are all various uh, hardware available. Okay, and coming back to our deck. So in this one, what are the information you can see? Um, okay, that one is, you can see the status, next available, device ARN, and some details about the processor, that is description. And then if you click more about this device, that will go to their website, Aspen Rigetti website. Then you will see um, the hardware provider name and availability, then whether pulse control is supported, native gate calibration supported, then region, cost. This is very important. See, task plus short, the number of qubits. So what is task, what is short that we are going to see when I demonstrated QAOA notebook. Till that time, please note that there are different costs involved. One is per task, other one is per shot. So the costing is one important aspect. Then also you can see more information about the calibration. The calibration, they will show the topology, what is the topology of the device. Then the data points, qubit spec, edge spec, say like the qubit 0, because it is 79 qubit, right? You remember it is a 79 qubit system. Uh, in a T1, T2 fidelity, and fidelity RB, fidelity and simultaneous RB, then readout fidelity, all those things will be displayed here. So if you take edge spec, let us see what is the edge spec. It will show the edge from this edge. What is that? C fate, C phase, get fidelity. If you want to more information, you can click here, understand what is this one. C phase. It is typical thing, but sometimes it may be useful. If you, actually, if you want to understand what is this fidelity in 41, I'm planning another session, the um, for the quantum computing related thing. That meeting may help you. But for the benefit of our to stay within the Amazon bracket execution approach and then demonstration, I'm not deep diving into the technical details. So I'm coming back to the devices. So this helps to understand what are the data points you can collect from Amazon for the selected devices. I would like to just explore the vector, sorry, state vector simulator. Let us see what are the points it is showing. See, this is a simulator, so calibration native gates are not applicable. Here you can see it is, there is no any pulse control native calibration, but here you can see the cost is 0.075 minute, and region west 1 west 2 like this, and it is a simulator. So simulator is a, actually it is a classical device running the quantum algorithm. So you won't get the actual quantum algorithm if you are trying something on the simulator. Then you may ask, then why should we need this simulator thing? But the simulator will help you to test your algorithm before running on a real quantum hardware. Because as I told you, you see here, this is the Rigetti aspirant, right? For Rigetti aspirant, if you run it for per task plus short, it is this much cost, right? So for running an algorithm, it may cost from $17 to $170, and harmony area is little bit costly. I will show you. IonQ area, see area 2, right? You see area 2, it cost 0.3 per task plus 0.03 per shot, and normally we will run for 1024 shots. So even one single execution will result in, let me run it, 1024 into 0.03, it's $30, correct, for one job. So if you run the same job or multiple times, the hardware cost will become more. That is the reason why Amazon recommends that first run everything on a simulator with the this lower cost, because you see here, I'll come back to the uh, this state vector, and this is going to cost you per minute 0.75. So if you run it as 60 into 0.075, so for 1 hour it is going to charge $4.5. Uh, so it is reasonable. We are able to experiment with um, whatever algorithm we are planning with the $4.5 cost. Then make sure it is working as expected. Then move on to the real hardware, where you can spend $30 or $300 or $3,000. So some of the models, if you increase the shots, it will easily go to $300 one job. So, and it is not only your QPU bracket, it is other supported services also. Those things also we will see now. Is it clear? I would like to come back to Q&A. If anyone of you have any question, please feel free to ask. I will answer. Then move on to the next step. It is okay to stop a while, then answer your questions.
Hi,
Yeah,
KG,
please.
Praveen here.
Yeah, Praveen.
Please correct me if I believe Amazon has a calculator, right? Inbuilt calculator.
Which one?
Where we can, Amazon in AWS, there is a calculator, right? Wherein we can project the cost as well, rather than going in a full-fledged. Probably if you are using any of the services for any amount of time or the shots, we can have a high level cost calculated, right?
The calculator for Amazon Braket, it is there. Let me show you. So I think it is cost calculator. Active notebooks device.
But if you go on the search itself, calculate search field.
Whenever you are am I there?
Yeah, yeah.
You are here, right? Okay. Suddenly I saw a network. Cost calculator.
Should be the AWS Cost Explorer.
No, that one is for billing, but let us see. There may be a.
Sorry if I diverted the topic.
No. It is essential concept because before knowing because whatever I told based on the way how I work, I calculated because I never use that because this is my cost summary. I don't want to.
Let me try from my side as well.
Yeah, please check it and then let me know because that interface is somewhere
Sure.
in the easy to see. Whenever we are creating a new services, we will do that one. Cost calculator. It actually is called cost calculator. So no, that one.
Just give me some time, KG. Let me. I'm also.
The pricing calculator is called. It is here. Calculator.aws. It is called calculator.aws. It's called pricing calculator. If we go here, I don't know why mine. Whether it is my network problem or yeah. So here you can go to this create estimate. In this create estimate, you can bring the services. Then it will tell you what is the upfront cost, monthly cost, all those things. See, select search below, search all services, and here bracket. So here, if you see, the Braket services came. Select this Braket services. So here also, what happened? It's added or not?
I could see in the bottom. It's there.
Oh, it will up. Okay,
it's
okay.
listed in the bottom.
For these things, we so these are all various Amazon services. But I feel because all these things our infra team used to do. Someone asked the question, D-Wave is retired. Is there any? It is there in Q&A, right? What happened to Q&A? You asked in Q&A, right? It's loading. While the AWS is loading, I don't know why this network is very slow today. Initially, it won't take this much of time. And region, let me select US East 1 and actually it is this much of steps we have to do. How many number of Amazon local simulators? 2 simulators and the duration maybe how to select this one. Okay, I'm assuming that 5 hours they are going to run. And the number of SV1 simulator, T1 simulator, this one is 2 hours, this is 2 hours, this is 1 hour, then 2, 3, something like randomly I'm giving. So if I expand the show calculation, so it is going to cost this much. It will tell all those things. Then I can save and add service like this. It is not only this one. I have to add SageMaker also. SageMaker is for running Braket. You need SageMaker. So I have to add the SageMaker. And again, like this, we can configure and then calculate. Hope this helps, Praveen.
Yes, Kesh. Thank you.
Now coming to the Q&A, there is one more question. It is there in the chat window. Okay, right. I don't know why Q&A is not working. Please type in the chat window. I will answer based on the chat window. Okay, Taposh asked the question. Since D-Wave is retired, are there other simulated annealing based devices? Okay, right. So as of now, D-Wave is retired from Braket, but D-Wave is available as marketplace. I will show you AWS marketplace. So it is not necessary to come to Braket. You can avail the D-Wave annealing service from the marketplace. I believe you know what is marketplace, right? We can provision their hardware as a Amazon managed image or directly their service like that. You can buy from marketplace. You see here, Leap Quantum Cloud Services. So you can use these services instead of checking this in the D-Wave, Amazon Braket. Similarly, Xanadu Borealis, earlier Xanadu, this is market research. I think Xanadu is not available yet, but I heard that they are going to provide. Right, it's not there. Xanadu, it is something different, but Xanadu boron is also earlier available. Now it is not available. I can show you here if you come. Okay, so hope that helps, right? Now coming back to the another question, one more question. Where is that window? Ah, there is other question. I used to IBM Cascade. That I don't need to worry about number of shots. Can you please explain a bit more about number of shots and its importance? Okay. So the IBM model is if you start a job, submit a job, the number of shots is determined by one of the parameter. In the parameter, you will select 1024, 2048, or 4096. So the number of shots, only 3 models available in IBM Qiskit, and IBM is not charging based on shots. They are charging based on the job. That's why you never worried about shots when you are running on IBM Qiskit. But in Amazon Braket, you have the 2 options. One is submitting as a job, the same way how we are doing in IBM Qiskit. The other one is task plus shot model. So if you choose that model, the number of shots will increase. The number of shots increases, your cost also increases. Now I'm coming to the second point. What is the importance of the shots, right? So being the probabilistic nature, the right, quantum computing is a probabilistic nature, and then because of the probabilistic nature, the more number of time you repeat the process, we can increase the accuracy of the particular job. So usually for high accuracy result, we will increase the number of shots and then run the job. So that is why it is flexible enough. And then it is not just the 3, you can give any number in the shots in Amazon Braket based QPUs. Hope that helps, Taposh. Okay, any other questions? Is there a question? What? Okay, cool. Hope Praveen, that calculator says what is the maximum number of shots people go with? Yeah, I have seen people running 10,000 shots also with 10,000 shots. I think in area, INQ area, we can run up to 10,000 also. But that is insanely, it will increase the cost. One run, it will go $700. Yeah, per job it will go $700. It's very, very scary. So it depends on the budget and then how much allocation you are having for testing these QPUs. Based on that, they will increase the number of shots. I have seen people running crazy about that one. The ceiling, I think, it is 10,000 only. Beyond that, you can't give. Even if you give, that won't take that much. But anyhow, I will confirm over a period of time. Whatever I'm telling is based on my 3 months prior experience where I ran that one. That was when I ran a production thing where I have to run on hardware with the increased number of shots. But these days I'm running only the academic session or this kind of demonstration only. Is there a difference in using D-Wave from Amazon Marketplace versus directly from D-Wave offering? Yeah, actually, see this particular thing, technically no difference. Whether you are running your algorithm on D-Wave from Marketplace or D-Wave from Braket, the technical result is same. But the costing and commercials will change. It is usually the vendor mm, vendor preference. Some vendors prefer to stay hand over everything to Amazon. Hey, this is my resource. I'm handing over to you. You share the service, bill the customer, pay a certain portion, or pay us this much of services based on the agreement. That is the bracket. Marketplace is something different where the vendor will manage everything. AWS just to give a platform to sell their product. So when you go for a marketplace and then buy a D-Wave service, you can you know very well that the requests, all the requests are processed by D-Wave systems. But if you allocate your service, or if you run your algorithm in Harmony, IonQ Harmony, or QERA, or OQC, Rigetti, in from the bracket, the entire platform, the entire hardware associated communication, everything is managed by AWS. So bracket is a fully managed service, but marketplace is not fully managed. Marketplace is managed by the vendor. That is the main difference. Got it? Someone is typing question. I will wait for another 2 to 3 minutes, then continue moving on to this one. Can AWS library be used in marketplace rather than D-Wave example icing model? No. See, if you are availing service from marketplace, the software framework is defined by the vendor. If the vendor provide an interface to your AWS simulator library, of course you can import that AWS bracket library, Boto 3, then run it. That is possible. But that is not case with all, and particularly D-Wave, their process, their annealing model is different. It is not. I did not see that that is not possible. Yeah, cool. Let us go back to our plan. Good. I like this interaction. That is really helps others also, because that question may be lingering over mind, thinking about asking the question. Okay. Feel free to ask questions. Stop me, because that is the real value of kind of sessions. And most of you already know, because you are repeat visitors, right? You know everyone, each other. So feel free to discuss as a closed team kind of thing. That is one advantage of our community. Okay, right. Let us continue the next thing. I will come back to question answer in another 15 minutes. So now we are discussed. This is Amazon services. This is what these are the hardware, all the available. Then obviously you may, if you are new or if you are attending first time, you think about what is these things. So we are talking about the quantum computers. Quantum computers are built on quantum mechanics. Then it is operating linear algebra of complex numbers into a Hilbert space, and qubit is the fundamental unit of quantum computers, and they are operating at a subatomic scale. That's the reason why we need cryogenic powered cooling systems, which are operating at minus 273 degrees centigrade, 0 Kelvin. That is very, very insane. That much of it, which is cooler than the outer space. It may cost 5 million to 25 million to build one quantum computer. It's a very costly affair. Right. Then what is a qubit? A qubit can be a spin of electron or polarity of photon, or there are many other systems which will mathematically show two positions: orthonormal basis state and superposition state. So superposition is a state where the certain percentage of all orthonormal basis states are being for example, if you toss a coin and then hold like this, that will be both head and tail, right? So certain percent of head, certain percent of tail is used to represent the state of the coin. Something like that, the electron or photon or any fundamental particle inside the subatomic scale can exhibit certain fundamental particle properties which can go to superposition. If you are able to identify those components and manipulate them, you can build computing devices. That is what the motivation behind building quantum computers. And it was proposed by Richard Feynman and Charles Bennett in the year 1981. Yeah, 1981. After that, the industries explore. They thought about thinking about let us explore quantum computing because it is very fragile because we are at a subatomic scale. People are not able to build such a sophisticated engineering devices. But suddenly in 1994, Peter Shor introduced an algorithm which will find the prime factor of very large integer number, provided that you have a powerful quantum computer. So imagine this way: you have a 2000 qubit system, and that qubit system can break your debit card pin number. What will happen to your money? So that is the first wake up call to the whole industry. We have to build a quantum computer because a quantum computer can break RSA key because of the prime factor capability. At the same time, quantum computer can give you more secured communication because it is a quantum mechanics, and then it is operating either single electron or single photon, those kind of very vulnerable, fragile communication medium that is more secure because anyone try to hack it, the sender and receiver come to know that your data is being breached. So that kind of secure system. Even you might have heard that in India, February 2023, we built our own quantum communication network between Pragati Maidan and NICNET Center in Delhi. So the industry, not only Indian military or Indian defense, the whole world defense researchers are pouring money onto the quantum computing because they want to build more secure net communication channel, communication, and more powerful systems to protect your data, all those things. That is where quantum computing gaining thing, and this is a typical architecture of a superconducting quantum computer. So here, yeah, there are, if they can mute if Deepa, can you check? Can you mute?
Sure, KG.
Yes. Whose mic, please mute them. I think you will be able to mute them, right?
Yes, yes.
Yeah, I found it. I muted. Maybe accidentally he might switch on the mic. All right. So then, okay, this is the other, actually misplaced this deck. It should be there. Now we are seeing what are the applications of quantum computers. So this we will discuss for the next 5 to 10 minutes. Then we will move on to the Amazon Braket demonstration. After that, it will be fully AWS Braket demonstration. I will demonstrate how to create user, then how to create notebook, run the notebook, see the result, all those things we will see. Okay. Hope this is good. Quantum computers are very powerful. They address a specific problem called NP hard or NP problems. So what is NP hard and the NP problems? These are all certain class of problem where the number of items increases, the time taken to finish the task will increase exponentially or factorially. For example, assume that there are some tasks. You are going to add 2 plus 3. Assume that your computer is taking 1 second to perform 2 plus 3. 1 second. If you add 2000 plus 2000, that time also it is going to take 1 second, because it is an addition operation. Even though the number in the value of the number increases, but it is going to take the same time. That is called a constant time. Sometimes there is a count. For example, you have to add two numbers. Like this, you have to add 100 set of numbers. Then the n increases, the time also increases more, because it is 100 set of numbers. We have to add 200 numbers, 2 plus 2, like that. So for one addition, it is 1 second. For 100 addition, it is 100 seconds. So it is linearly increasing. Sometimes there are n numbers or n names. You have to identify um, not names. Assume that there is average salary of 100 software engineers. You have to find out the average. After finding the average, you have to find out the number of software engineers below average, the number of software engineers above average. So this is a nested loop, right? For loop inside for loop, like that you have to increase. This kind of problem, if n increases, your time will increases either polynomially. So that is a polynomial time complexity. If you increase the complexity of this calculation, even a small n, your time will increase exponentially, meaning that for 10, assume that for 10 items, it took 10 seconds. For 11 items, it won't take 11 seconds. It will take 20 seconds. If it is 13, it will become 40 seconds, like 2 power n. That model, it will increase. So if that increases that way, even a small increase will cost a lot of time in the classical system. Those kind of complex problem can be effectively solved by quantum computer. Why? Because quantum computers, because of the superposition, entanglement, and interferences, it is offering massively parallel computing capabilities. Those capabilities can be used for solving this kind of NP hard problems. Now I'm coming to the actual AI and ML problem, like the application of quantum computers. So in AI and ML, there is a concept called feature identification or feature extraction. So if there are 12 columns in your data points, only few columns will give or will help us to predict or classify, or whatever the machine learning model we are to do, deep learning, whatever it is. Few columns will be more important. Identifying those few columns is called feature extraction. This feature extraction is a complex operation because it has to it is actually NP hard problem. It's a exponential NP hard problem, because O of 2 power n or O of n square, then O of 2 power n or n power n minus 1. Some complexity will come. So here, increasing one more feature will cost a lot of time for the classical system. But whereas quantum computers can put them into a fundamental property called angle, then angle rotation will help you to identify the features that can be fed into another classical model. If you put that one, a quantum computer can help to identify the features in a polynomial time rather than non-polynomial time. That is the reason why there is a quantum artificial intelligence, QAI, then QML, quantum machine learning. Actually, this is my area, because prior coming to the quantum career, I was a data scientist. There I worked on classical machine learning models. I built end-to-end solutions. So I thought that it is good to logically progress to the quantum machine learning. That is what my progress. So if most of the software engineers are data scientist with easy to enter into quantum machine learning naturally. Then comes someone, I think someone asked a question. There is a question I will answer, otherwise no questions. Okay, cool. Sorry for that. Then computational chemistry. As just now I told that I am a data scientist. I know about the computational chemistry. But wherever I go and then talk about the quantum computing, most of the sessions, chemistry team, people from chemistry domain will come and sit there. I really wondered why chemistry people are want to know all those things. That's when I came to know when I talked to chemistry professors, they told computational chemistry starts with the quantum states. They always worried about E psi equal to Si. That is the formula, Schrodinger equation. So that equation starts from quantum mechanics only. It cannot be done with the classical. So the computational chemistry needs quantum computing equally like artificial intelligence, data science domain. It is really very interesting to know that the quantum computer can help computational chemistry to identify lowest energy of molecules or protein folding or prediction, which will result in drug discovery and development. That is the next application. The third one is cybersecurity. Remember, I talked about Peter Shor algorithm, which can break very large prime number into the very large integer into the prime factor. That is the falls under cryptography. Then cybersecurity is with the communication channel. With a single source photon or single photon source, you can build a secured communication channel which cannot be hacked by any external system. But it's very fragile. The external interference will impact, but still industry is able to build cyber security communication channels. There are organizations who are working on that one. There are many organizations. From the academia, you can hear about many news about RRI, Raman Research Institute, Bangalore. They are into building the communication. Then ISRO, and then there are joint venture among Indian DRDO supported, funded organizations. They are trying to build secure communication channel combined with the quantum key distribution and quantum channel for data transmission. And also they are planning to build algorithms for encryption because the classical systems are using prime number as the RSA or Edelman, whatever it is, they are using prime number, right? In the post quantum, they supported the lattice based calculation, which will be very strong. But quantum is promising their own approach for building the strong mathematical model, which cannot be broken by any systems. Then the financial modeling, that is very interesting because Monte Carlo simulation, then you can where the Monte Carlo simulation can be used. If you are aware of future and options market, where we are trading on derivatives like Bank Nifty, there are many feature and option symbols. If you trade on them, because they are derivative, their volatility is very sensitive. Even a small change in the real business, the equity will not affected, but the derivative will be affected. Say for example, if you are buying on SBI share, that is equity model, you can confidently or you can comfortably keep the share even though the SBI price is there is a fluctuation, because you decided to keep the share for another 5 years. You need not panic because over a period of time, anyhow SBI share is going to increase. So now may be a loss, but the same share will grow in 5 years. So you can feel comfortable. But if you buy the Bank Nifty feature and option, that is a short span of time because 1 month contract. Within that 1 month, you have to predict correctly. So which selling price and which strike price, whether it is call or put option, those things you have to decide. That financial modeling is an NP hard problem. that can be done with quantum computer. In classical, there is a formula called BSM, Black-Scholes method. That BSM classical model can be implemented in not exactly with the change, with the necessary change according to the quantum computing mathematical model, it can be done. The same thing used for logistics optimization, because most of the logistics problems are can be considered as either max or insatiability or what is this traveling salesman problem. Okay, so the traveling salesman problem or NP hard problem, and then the massively parallel, that can be done. I know there is a project with the Netherlands and one of the logistic provider from China. They are working on the supply chain and the logistic optimization for optimizing their transportation through the northern part of Europe and Asia, because that is very, very unpredictable, extreme weather, that northern area. So that is the thing. Then weather forecasting, obviously weather forecasting has a lot of parameters, and it is when even increase one parameter, you add one more parameter, it will proliferate exponentially. That is the reason why weather forecasting is the one of the applications. There is a question. Manoj asked the question, may I know why quantum computers are fast? Can you please let me know about qubit? Okay, first let me answer the why quantum computers are fast. Okay, let me go back to the previous slide where I talked about a qubit. From there I will explain. Yeah, you see this Bloch-Spear, and then this one is what is called the spin up and then spin down position of the electron. And also there is one more thing you have to remember. Yeah, let me take this pen. So what I want to show you, it is the polarization of photon, vertical, and another position is horizontal. I'm talking about the polarization of photon. This is horizontal, right? This is vertical, this is horizontal. So vertical, horizontal. But sometimes the polarization can go 45 degree, which is superposition. So the superposition mathematically return us alpha 0 ket plus beta 1 ket. Here this alpha and beta are probabilities, and this is for 1 qubit. Imagine that if it's a 7 qubit system, you can place 7 qubits near, then they can be entangled also, and these operations are happening within one block box. So within this one, whatever if you make the superposition and then perform some operations, all those things will happen parallelly till you are measuring. That is the point you should remember. So this data till measuring within this place, it will run parallelly. Because of this parallel superposition and then entanglement are happening within that black box, everything in parallelly, quantum computers can process the information massively parallel fashion. That's the reason why they are very fast. How can you visualize this one? Imagine that there is a spherical football ground. It is not normal flat football ground, and then there is one football. That football, after kicked, it will reach the sphere of that football ground and stay there only. So it can go anywhere in that one, and when you measure, it will give one position. So are you able to visualize this one? The ball is in the middle of that, the football is in the middle of that spherical football ground. It is initiated, then it's touching the wall, the spherical wall of that ground, and rotating there only, moving depending on the external energy or some energy, it is moving there. After some time, it will stop. That time you measure the value, that is your result. This will happen very fast. So like that, if you put multiple days, and then if you make change in one football ground, that will impact the football in the other football ground. That is an entanglement. So if you make one change, that will impact other grounds also. So 7 qubit means you can imagine 7 football grounds, spherical football grounds. You can visualize this as the Harry Potter Quidditch game. You remember that there is a game in Harry Potter Quidditch like that. So there will be one ball which will go there and then rotate there. Beyond that, it won't go because it is a Hilbert space and unit vector. The sphere is the unit vector, so it will stay within the sphere only. It won't go out or it won't come inside. It will stay there only. So because of this capability, qubits or quantum computers are very fast. There is one more question. How is the quantum technology field for the one who is not from physics mechanics background? If someone is from computer science background, with what all the concept of physics he need to know to join the quantum computing? This is very question because I can connect this question because I'm a software engineer. Thanks, Sub, for asking this question. I'm a software engineer. As I told you, 15 plus years of experience in software engineering, then moved to data science. There I was more than 6+ years. I worked as a pure data scientist. Then only I moved to quantum computing because of the quantum machine learning. That is the path. But when I decided to pursue quantum computing as my career long time back, I came to know that mathematics and physics are essential. Without these two things, I can't understand what is happening in the quantum computing. See, now you have Python packages. You have Amazon Braket. Inside the Amazon Braket, you have a lot of Python modules which you can write, and then there are alternative organizations. They are providing a lot of Python-based frameworks you can import in your Python. But when I started, there is no Python interface. It was only there is a language called QCL, quantum computing language, which is like C++. When I read the examples, everywhere they put alpha a ket alpha 0 ket plus alpha beta alpha 1 ket. That itself I'm not able to understand. When I deep dive that into tour, I come across Blochsphere. Then I realized I have to understand complex number and that operations. Most of the operations are Kronecker product. It is not simple multi standard product what we are doing. It is a Kronecker product. Then I have deep dive into Kronecker product. Then I realized that I should be strong in linear algebra of complex number, not real numbers. Then there comes functional analysis. The functional analysis is the branch of mathematics which allows you to create new operations. So, and most of the operations are on the fly created because of the quantum behavior. To understand that one, you should have a good idea about or at least a fundamental idea about the functional analysis. So mathematically, you should strong in linear algebra and complex numbers and Hilbert space. Then those operation matrices, vertices, all are on the complex number. That is one thing on the mathematical side. When it comes to physics side, you should be able to understand the quantum mechanics. So straight away trying to understand quantum mechanics, it's a painful task because I would like to share what Richard Feynman told. Yeah, this is what Richard Feynman told. If you understand quantum mechanics, you don't understand quantum mechanics. So this kind of complexity is there. So you have to understand from the fundamental particle level to some level chemistry, then Newtonian mechanics, quantum mechanics, how quantum mechanics different, then quantum mechanics behavior like superposition, entanglement, interference, and there are many few more things which not necessary, but these three things are essential. Then how these things are mathematically explained or demonstrated or represented and manipulated. If you understand these things, you are good to go. A good start is that you read this book. I will, because since my screen is shared, I can show you this book, quantum information, and yeah, this book. This is the good book to start with, but initially it will be intimidating if you read alone. Get help from mentors. Try to learn. Say this book I'm referring. This is the one book almost all quantum computing professionals might have read at least twice or thrice in their career. This is a good book. It is Mike and Ike, Michael N. A. Nielsen, and then Isaac Chong. Yes, Nielsen book is correct. So this book is the good starting point. Then my personal preference, this book, Quantum Computing for Everyone by everybody, Chris Bernard. Yeah, this book. This is one good book. Again, this also heavy on mathematics, but not intimidating like Mike and Ike book. Then, if you have time, this Dancing with the Qubits by Robert Suter. It is very plain English. It's really interesting to read. If you're a person who likes history and what happened with those interesting stories, quantum theory in physics. This book, yeah, quantum theory, a graphic gate. Yeah, right. This is also one good interesting book. So these three books will help you to come to stage. Then from there you can apply your computer programming knowledge. In programming also, you have to, since you are going to work on NP hard problems, the whatever technique so far you have learned with the classical systems, they need to be modified, or you have to think through different thought process. Hope that answers your question. Cool. In where am I now? Okay, kind of lost. Okay, right. Okay, so hope you understood. Cool. With this one, let us continue our discussion. Feel free to stop me because now we are going to see. I will cover up these things in another 9 minutes. Then I will start the demonstration. Okay, so after the application. Okay, right. So the quantum gates, since quantum computing are based on the linear algebra and complex number operating on subatomic scale, they have the entirely different operations, not like AND OR gate, what you are seeing in the classical systems. Here, these are all behaviors around that quantum systems. So there will be X rotation, Y rotation, Z rotation. Then Hadamard is the superposition. Then phase shifting, which is phase, and then T gate, then C naught, CX. CX is the entangling gate. It will allow you to entangle. H is the superposition. So you have to make Hadamard gate, then perform operations. That is the usual thing. Then at the end you have measure. You can swap the qubits. Swapping is not possible in classical, but in quantum it is possible. There is a Toffoli gates which is CCX, meaning that you are entangling 3 qubits. So entangling means making connections. So any change in one qubit will affect other qubits. That is the entangling thing. So for that, they have the specific matrix. So out of this one, please remember this Hadamard gate, which is 1 over square root 2, 1, 1, 1 minus 1. So, and these are all matrix multiplications, standard multiplications. Since these are all square matrix, 2 by 2 square matrices, everything is square matrix only. This is 2 by 2, this is 4 by 4, this is 8 by 8. So all the square matrix multiplications will give you the relevant result. And these gates must be placed in a horizontal line. That is what quantum circuits. You can see here, this is a quantum circuit. These are all qubit lines, and this is a single qubit, this is 2 qubit gate, and we are measuring. So measuring is the final result. Without measuring, we can't find the result. So quantum circuits are built in the horizontal time sequence model, where you are placing your quantum gates as per your statement of problem. How that is, how you are determining which gate for which operations, that is where quantum algorithms come into picture. So there are multiple algorithms. These are all popular algorithms. Remember, I talked about Shor's algorithm for prime factoring, Peter Shor algorithm, then this Grover algorithm for, excuse me, for the unstructured data search, Dash Josha, Benson Vazrani, Simon algorithm for bit string manipulation, then quantum Fourier transformation, quantum phase estimation. Actually, these two things are used in Peter Shor algorithm. Then hidden shift problem, quantum key distribution. These are all, actually we call this, these are all foundational or fundamental quantum algorithms. They are it is necessary to understand all the algorithms from the mathematical perspective, then physical phenomena perspective, then implementation perspective. All algorithms, there are three things: mathematical model, and physical phenomena, then programming implementation. There is one question: how the quantum gate is reversible? See, reversible comes, you think about AND gate. AND gate, I'm talking about the classical AND gate. 2 inputs, 1 output, right? So if the number of input is different from number of output, these gates are not reversible, because for reversible, the number of input and number of output must be equal. Only those gates are reversible. The next property is that if we give some input, we'll get some output, right? If we give the same output as in this direction, we will get the same input. Those gates are reversible. So those things are mathematically represented using the polymatrices. Those, remember, I showed you the polymatrices. That polymatrices are reversible gates. This is this. Oh, the square matrices, these are all polymatrices. If you perform this direction and that direction, you will get the answer what given here and output. If you perform this direction, see, for example, A into B, you will get C. C into this B, you will get A. That is the reversible. It helps to understand. Okay, with this one, let us move on to the algorithm we are seeing now. And there are some popular algorithms which are used for applications. For example, the VQU, variational quantum eigensolver. It is used by computational chemical problems, because that can help you to identify the energy level of molecules. Then there is one more algorithm called quantum approximate optimization algorithm, which we are going to say, I have to, the spelling mistake, I will correct it. All of you will have access to this deck, so you can download. Later our team member will share the URL from where you can download not only this video and then this deck, our previous contents also. Then quantum neural network, variational quantum linear solver, there are many. I listed very few here. If you want to know all popular quantum algorithm, I recommend this particular website, Quantum Algorithm Zoo. There is a website called Quantum Algorithm Zoo. Yeah, Quantum Algorithm Zoo. You go to this website, you can find almost all popular quantum algorithms. And this is a good starting point for anyone who wants to pursue quantum computing as a career, because that will give you what are the existing algorithms already proven, what operations they can do. Understanding that will help you the real capabilities of quantum computer. Here everywhere they will mention that complexity of one queries, and you see here it is big omega root n, but originally it is O of 2 power 0.5 n, something like that. How this polynomial speed up you are achieving, all those things, and then this is super polynomial factoring, all this complexity. It is a good starting point for learning quantum algorithms. Okay, with this one, let us continue. Um, the next slide. See, next is a demonstration, which is I'm going to demonstrate with the AWS account. Please note that whatever I'm going to do now, that will incur cost for MyQT due to the consumption of AWS resources. Here, actually, next week we are planning to start a session, a workshop for Amazon Braket, where all of the member who are going, there is a paid session where they will be given 5 hours of Amazon Braket time, where they can practice their preferred algorithm. Announcement will come later in the social media. Those who are interested, they can join for that workshop. Now let us continue our QAOA demonstration. Actually, here you can see here the classical machine learning. We are using QPU, right? QPU. What happened? It's a copy of this one. Right. Yeah. So I will make corrections now. So sorry about it. Cool. Slideshow. Question from current slide. Right, today it's very slow. It's slow. From slideshow. From current slide. Yeah. Okay. So one good thing with this current approach is that in the classical systems we are using GPU. Just imagine that GPU is replaced by QPU. That's it. So other things are same. So only the complex calculation is delegated to QPU. So in future it will be always CPU plus GPU or CPU plus QPU. Quantum never replace classical systems. Please be aware that quantum computers are complementing classical systems. They are not replacing. They cannot replace. That is the fact. Okay, with this fact, let me start our demonstration. Let me go to our, okay, this is, this process, what I'm going to show now, that may take some time. So it is a demonstration, right? It will take some time. So any other questions, feel free to ask the question, keep asking question. We have another 28 minutes.
KG, there are questions in the chat window.
Did I miss that one?
Yes, that came after that section.
Oh, okay. Let me check it. Sorry, because I'm in another window. Yeah, reversible gate I answered. I think Sub, you got the answer for the reversible gate. Am I right, Sub? Okay. Or work on some problem.
Yes, sir. I got.
Domain knows play an important role. As I am from physics background, which quantum application like drug discovery or weather forecasting or logistics is best for me? See, if you are from physics background, I recommend simulation and optimization. See, simulation is one problem where quantum computers can really add value. Here, whatever simulation we are having now, they are simulating the natural behavior by approximating the value. Because of the approximation, we are losing the accuracy. But a quantum system can accurately represent the natural behavior. The reason is that quantum computers are using complex numbers, right? Remember, quantum computers are using complex numbers, but classical systems are using binary number. So when you try to simulate a natural behavior, you have to convert the value of the natural phenomena into classical binary number, where you are doing approximation. But in case of quantum computer, you no need for approximation. For example, if you are trying to build a simulation for weather forecasting, all the parameters of weather forecasting can be directly represented without any approximation into a quantum system. Then you can apply the various quantum gates, and to get, when at the end when you measure, you will get the behavior, or you will be able to simulate the natural behavior. So simulation is the good for people from physics. Next one is optimization. The optimization will help like to identify the global minima. Any problem which you want to find the global minima, that is a good candidate for optimization. Of course, that is effectively done by annealing devices, but gate-based systems. So either it's a gradient descent or some other approach for find global minima. Those approaches can be effectively built using quantum computers. So my recommendation is that focus on simulation and optimization, because drug discovery is suitable for people from chemistry background, and logistics, those things are suitable for people from computer software engineering or business domain. That is good. If you are from physics, you can play a higher role by building the simulation of the natural systems or any physical systems. Hope that helps, Abhay. Okay, right, good. Now come back to the demonstration. So usually for working on Amazon Braket, you should create a user by going to this IAM. This IAM is the service in Amazon which allows us to create credentials such that the end user can log in and then do the create necessary resources, either it is a notebook or S3 bucket, those things. So here, what we have, actually we have a lot of users practicing our account, but those things I deleted. Now from the last demo, I have 15 user. I'm not going to open that one. So usually we will click user like this, then create new user, give a name. For example, assume that I want to create an user for Vinesh at some.com email ID. Then I will go to next. Then here I have to give the permission. So the permission is very important aspect. If I give permission to all things, I have to give minimum 6 permissions. I will show what are those 6 permissions. If you want to work in Amazon Braket, certainly you need to access to IAM, then Braket, then SageMaker, and CloudWatch, S3 bucket, and CloudWatch log. So these are all the necessary permissions. Actually, remember I show one place where I purposefully left it blank. is this permission thing. IAM full access. Yeah, my Qt bracket simulator only. Here you can see here IAM and then SageMaker. Yeah. These are the 6 services: S3, SageMaker, IAM, Bracket, and CloudWatch service quotas. These are the necessary permissions you should have to work on Amazon Bracket. Hope this helps. So this is where this image will come. That's why I left it blank. I just wanted to show you this is the data. Yeah. Later, when you access this one, it will be useful. You can recall that. Okay, right. Coming back to this one. So I can create a user like this. After the user is created, now I'm going to use my account, so I don't need anything. After that, what you have to do, you have to go to SageMaker. SageMaker is a service where you are going to create your notebooks, your program. For example, this is the program I'm going to do. This is the QAOA program, what I'm going to do now, demonstrate now. For that one, I have to create a SageMaker notebook. So inside my account, I have to go to SageMaker. Yeah, here I don't go for studio. Scroll down, you will see notebook. Go to notebook and come to notebook instances. This notebook instances, you can see a lot of notebook instances. Let me go to, no, I don't, I want to create a new one. Create a notebook instance. So this is the notebook name, and then you can see here this notebook is using MLT3 medium. That's the reason why any Amazon Bracket training or the practice, even though you are using simulator, this SageMaker notebook will consume this instance, so that cost also will go. So there are 3 components in your AWS Bracket billing. This SageMaker, then Bracket, third one is S3. I will show where that S3 comes into picture. So, and then here the permission, you should have a role. I always use this role because earlier I used this role, but this role is an execution role, which will give the necessary permission. Then network, all those things, if necessary, we can create. After that, if you create notebook, what it will do, it will create a Jupyter notebook instance where you can go and practice or create a new. See, now the notebook is created. So notebook is created. You can see here the status is still pending, which means it is provisioning. After it is ready, I can click this one and then go and then create my notebook. So here I have to, let me refresh. Still it is pending. If there are any questions, I ready to answer. Otherwise, I will continue. Okay, right. There are no questions. So now you are following, right? Make sure that you have account in IAM. Then create a notebook instance in SageMaker. Go to the notebook instance. Then yeah, it's still loading. Otherwise, see, otherwise this open Jupyter lab will be enabled. Now it is disabled, right? Because the status is pending. It's created time, blah blah blah, just showing. And let us wait for this one IAM role. Okay, all those things, it will take some time. Hopefully it should solve in 1 or 2 minutes now. While it is loading, I will explain the S3. See, now remember you created a notebook, and that notebook is going to hit a QPU or simulator. Now the results and this program might be stored in somewhere else, right? That is the way. S3 is a way for integration or interface between your notebook and QPU. The QPU will update your S3 bucket. Your notebook will read from here, or that S3 bucket can be read by any other program, Boto3, using Boto3 interface. That is why your Amazon Braket workflow involves 3 costs: S3, Braket, and SageMaker. So be aware of these things. Since it is taking a lot of time, I'm thinking why should not open an existing that is also stopped, right? Then starting that also will take equally this much of time. Since these notebooks all will cost, we usually stop the processes. Okay, there is a power failure in our area. Sorry about it. Okay. I think I can stop my video. Maybe that may be the reason why the performance is very low. Oh my God. I want to show this writing a program and then still pending. Okay, let me go back to one of my sample program what I did. Now it is ready in service. So when it came to in service, either you can go here and then check for Open Jupyter Lab. We click Open Jupyter Lab. That will open the Jupyter notebook. I'm not sure, or I believe that all of you know what is Jupyter Lab. It is a Jupyter, an IDE for writing Julia, Python, and R language. That is the word Jupyter. Julia Python terminal. It is meant for Julia language, but later Python adopted that. People are. It is more popular because of Python, but originally it was written for Julia. That word Julia Python terminal. That is the Jupyter. Okay, so here I can create a new program. It should be Python file or Conda Python, Conda TensorFlow. I will select Conda Python because I'm not going to use PyTorch or TensorFlow. I'm selecting the notebook Conda Python. Here I can rename it. Let me rename. Sorry, KAOA. This is the program what we are going to do. So obviously I'm going to refer this program and this link I will share in your chat window such that you can and these links I have given in the deck also, so you can get it from there. This one, the bracket tracking, this will allow you to track the time you spend on your bracket. So always put it here, then you can run. It's telling no module named bracket. Obviously, whenever you are building that one, you have to import necessary bracket, necessary modules. So I have to import bracket. It's not just bracket. Let me delete these things. I'll come down. Yeah. See, this is the bracket from Braket AWS. So this is the bracket related imports. So let me import these things. Here, if you face this package is not available, this package is not available, you have to run the command exclamation pip install whatever that. For example, if it is telling network is not there, pip install network X. And sometimes the name may be something different. That time you have to import the right package. Okay, be clear about that one. Then next one is I have to import this bracket thing. So I'm importing this bracket related bracket circuits, bracket AWS device, then local simulator. We are not going to use local simulator. I'm going to run on a simulator device. Okay, so here no module name to bracket. Oh my god! If that is the case, pip install. It's not just a bracket. It is. I'm giving you an idea because you search like this, then find out the correct name. It is the installation is pip install Amazon Braket SDK. So that is the command you have to run. Select this one, then pip install Amazon Braket. Then it will install all these things. Okay. So it will take some time to run it. So it is taking time, and then it will install everything. After that installation is completed and you can see successfully installed, then you can run this cell. These are all intricacies of running an Amazon Braket. That is the reason I am demonstrating. We have another 10 more minutes. In the interest of time, what I'm going to do, since I'm planning a workshop, I will not go deeper into this explanation. This demonstration is for Amazon Braket, how this Amazon Braket, not QAOA. Because understanding the QAOA, so this is that QAOA notebook. You can see here you have to understand this, the background of the QAOA. You can see the formulas, how this ket alpha comma beta, sorry, gamma comma beta equal to, it is an unitary operations. Those things you have to understand. Without understanding these things, running the program will not helpful. And to understand, before going to QAOA, you have to understand QBO also. QBO is the quadratic binary optimization problems. So mathematically, what are the problems can be solved with the QBO? Then how this VQE, variational quantum VQA, variational quantum algorithms used to build a variational quantum circuits for solving optimization problems. So this much of theory is behind that to understand QAOA. But our focus is for Amazon Braket. Considering that one, these are the introduction. You have to create SageMaker notebook. Inside the SageMaker notebook, you have to create a Jupyter notebook. Then type the program. After the program is typed, you can execute. So after the import, let me create the random seed. Random seed executed. Then this already I imported from utilities classical import, plot colored graph, all those things. Okay, let me import this one as it is. Utilities classical. I have to run it. Install, sorry. Install utilities classical. Find a version satisfies version. Not much in this solution form. Okay, utilities classical. What is the mistake I made? This utilities classical. when is the next episode date and time? Actually, every free workshop or every alternative Saturdays, but the paid workshop we will announce Monday or Tuesday about the date and time, because it is being a online session. We have to check for what is called preference by all the team members. Oh my god, it is class something very there are a lot of operations are coming. No, I have to search for the exact error message. No module name details class. Let me search this. So this one you will realize that I don't remember these things. I don't keep remember this. We will enable you. So actually, ping your number. Deepa will coordinate with you, then help you to those things. As of now, this is fully on the. There is no website link we have provided for the payment. Um, we will pay. We will share the UPI ID or our MyQT account. You can transfer there. Yes, though the detailed brochure will be shared. Yeah, those who are interested, please ping Deepa, share your number. Deepa will follow up with you. Actually, why this? Like we can ignore this one. That is not a big deal. Then because they are running local simulator, but I want to run these. I don't prefer this local simulator, so I'm going to run on the SV1. So I'm copying this code, exactly this code. Run this code. So I'm creating device using state vector simulator. Okay. So now it has created the device equal to AWS device. Then I'm setting up the problem as per this one. Let me show. Okay. Here is that problem will come because of that color network. Hopefully it should show. It's working. See, this is the chart is coming because this is the network X NX. You can see here this import network X NX. This is a Python package which will create the mathematical graph. I believe that most of you know what is graph theory and then how these graphs are created. The graphs will have node, edge, face. But in this problem, we are focusing on the node, and each node will have some weight. Based on the weight, we are going to perform satisfiability or max cut, or those things will be used for excuse me, traveling salesman problem. Okay. And see, actually there are only 4 minutes left. I would like to stop here, but this is the way how to run these things. Later feel free to connect with me or Deepa. We will help you to enroll for the workshop. That workshop will be 12 hours duration. Out of the 12 hours duration, 4 hours you will get 4 hours of Amazon Braket support state vector, any one of the simulator, not the hardware, only simulator access you will get. So that will cover up the cost. You will be taught the Amazon Braket account creation, all those things, then the QAY algorithm, and any one of the quantum machine learning algorithm based on the penny lane. 2 algorithms will be explained, and certificate will be provided. Actually, those who enrolled, they may be given internship with our associate organizations. We are networked with multiple organizations who are looking for quantum computing interns. We will place you there. Yeah, this is the end of today's session. I know that I cannot demonstrate this one because that involves cost also. So I'm going to stop the notebooks now. But this recording and the PowerPoint deck as well as the Amazon Braket link, those things will be shared. So if anyone who are ready to self-learn, you can learn on your own. Cool. Cool. Great. I'm open for question and answer for the next 2 minutes. I'm looking for, yeah, here. Yeah, Taposh. So also you can, anyone who's interested, you can ping me in WhatsApp with this number. And Deepa, share our email IDs and WhatsApp group link. I believe the session was useful for all of you. Any feedback? Yeah, Deepa, over to you.
Okay, KG, I shall share the email and WhatsApp number in the chat window plus in our community group. So those are interested can join, can ping us. Okay. Is it concluded, KG? Shall I conclude it?
Yeah, yes. Yeah, we can conclude. Please go ahead with the word of thanks and then conclude.
Thanks, KG, for your excellent presentation on Amazon Braket. It was a clear, concise, and informative section on Amazon Braket. Thanks to all the participants for your time and effort and your active participation in the discussion. Okay, your questions and insight helped to make this section even more informative and valuable to the other participants too. Your contributions were invaluable to the success of the event. Our team is looking forward for your active participation again in future. And you can send your feedbacks and attaching the link on the chat window. So you can send your feedbacks and your what you prefer for the next session, etc. can be commented on that link, or you can chat. You can type it in the chat window or make us know through any of the medias or chat that what section you are needed in the future. And this, so that these feedbacks can help us to improve our upcoming sections. Thank you to one and all, especially KG and all the team members, those who have cooperated with me to make this section a successful one. And once again, I thank all the participants for spending these 2 hours keenly observing KG and asking questions and making this section a wonderful one. Thank you one and all.
Thank you. Have a great day.
Thank you.
Shubh, I shared my LinkedIn profile. You can search for Karthiganesh. Cool. Thanks, team. Thank you. Bye-bye.
Yeah, thanks, sir.